Hey everybody, Miss Barry here. Going to go ahead and graph some piecewise functions for you. Right here in this example, I have two pieces. I have f of x is equal to 5, f of x is equal to 3x minus 4, and those specific pieces do have some interval notation for us. In this case, it's written out as an inequality to kind of help us dictate what's in play and what's actually not in play. So the very first function I would do is going to be this 5 right here. I would recommend color coordinating this if possible with different colored pencils. So 5 is just a horizontal line. Reminder that when I see f of x, it's another way of just thinking about the letter y. So I have y is equal to 5. In this case, a horizontal line at the location 5. I'm going to go ahead and draw some dots here. All of these dots have a y value of 5. So again, I know it's a horizontal line because there's no slope. There's no variable x in this problem. So all of those dots, this line right here would be the line y is equal to 5. However, what I need to do is make sure that I understand that my specific interval, written as an inequality right here, x is less than -1, is going to really restrict what I can have. I'm not going to have the full line that I just drew out in dots. So I'm going to erase everything that does not apply. In this situation, I need to have numbers that have x values that are less than -1. Since it's got to be less than -1, all of these positive dots with positive x values, they're going to go away. There's no positive x value here. That's going to be less than -1. 0 doesn't count either. 0 is not less than -1. Then I come to the actual location. I have that -1. I need a dot there in some shape or form because I need a spot to kind of set up the barrier. That's where this particular function is going to end. And because I don't have a line under that arrow, I'm going to go ahead and give this dot right here a open circle. So again, the open circle here on the -1 because it is an excluded point. Apologies for the bad writing here, but I think we get the point. Everything to the left of that would have x values -2, -3, -4, -5, so on and so forth. So we're heading off to -infinity on that side. The second function here, y is equal to 3x minus 4. Hopefully we recall from the video, if you need to take a look from Algebra 1 at the beginning of this Nearpod. My slope is going to be in front of that variable, the coefficient. And we can go ahead and think of that slope as a fraction, 3 over 1. My y-intercept is where I'm starting. So the point -4, the y-intercept will have a value right there of 0, -4. And from there, I will go up 3 into the right 1 because of the positive slope. Up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. I could do the opposite of that also from the y-intercept. So instead of going up 3 into the right 1, I'll go the other way, down 3 into the left 1. Again, I need to check out where's this going to end. -1. It does have a line underneath the arrow there, so I'm going to go ahead and make a solid colored in dot at the location where our x value is -1. And then all of my x values that are greater, like 0, like 1, like 2, like 3, like 4, and so on and so forth, are going to count in this situation. So I'm good to go ahead and connect these dots as best as I possibly can. Hopefully you're drawing a lot better than I am with this mouse. And I think hopefully you get the point. So this right here would be my piecewise function, excuse me. It includes that blue horizontal line with the excluded point at -1 because the arrow doesn't have a line underneath it. And then I have my red line, 3x minus 4, with the understanding that that go ahead and that starts at an x value of -1, and then it goes on from there.